So hello everyone, I'm Valdas Maksimavicius and I have a question for you at the beginning. What are the most difficult problems in IT? Cache invalidation, and the second one? Naming, exactly. And it even applies for Microsoft. So look at those services. We have Microsoft Machine Learning Server, we have Azure Machine Learning Service, then we have Studio, then we have Workbench. What the hell? Are they not capable of finding different names? And then there is Microsoft R Server or Data Science Virtual Machine. And what do you think? How many distinct services, different services, do you see here? You don't have to answer now, but just keep in your head. We'll go through those over the presentation. A bit about me. I moved to Lithuania around 10 years ago, and then I had to deal with, I was born in Poland, and in Lithuania had to deal with immigration office, and they were quite surprised, like everyone is moving out of Lithuania. What's wrong with you? Why are you coming here? But I love this country and I like this city, and now I'm 12 years here, and I work at Cognizant. And the arrows to Oslo and Stockholm, so I'm traveling quite often there. I work with clients with insurance, pensions, banking there, and mainly with Azure solutions, Azure data analytics solutions on Azure. I started my journey with Azure in 2015, and I said this quite stupid quote, that with a few clicks, you are able to get Hadoop cluster up and running. So yeah, this is true, but if there is only way to send message back to myself, it would be this. So basically not everything is that simple. Like it requires time and effort, and especially like having cluster, yeah, that's a few clicks, but making like some use of that requires much more work. Apart of that, I would like to encourage you, if you haven't heard of Vilnius Microsoft Data Platform Meetup, and if you are enthusiastic and would like to share something about it, so please contact me, and if you have something to share, we can arrange a meetup and we can share something about your experience. Another point, organizers already, you are pretty familiar with Slido, but in addition, I have a few gifts that Cognizant marketing team forced me to bring. So I have a few books, I have a few water bottle, cup coffee. So I encourage you to ask questions and even mention your name, because then it will be, I will know who asked that question or come and grab your gift. So inspiration for this talk, the first one was this. And here I want to talk about something like, imagine that this bear is chasing you. So the last thing that you will think of is writing a poem about that. Maybe a year from that event, if you survive, then you will think about writing a book how you survive a grizzly attack. But not at the moment when this grizzly goes after you. So the idea here is Maslow's hierarchy of needs. We have psychological needs, we have safety needs, and then we have self-actualization, creativity, or like writing the book. And there is something like that with data science. There is data science hierarchy of needs, where we have data, we have infrastructure, some tools for data preparation, or deep learning tools. So in my talk, I'd like to focus on this infrastructure level, on what different tools we can give to data scientists. And another inspiration is, as I already mentioned in the video, that Microsoft has plenty of different ways to solve the same problem, actually. And this is the print screen I took 1 week ago at Azure Portal. And we see machine learning workspace, machine learning model, and then we have Machine Learning Studio Web, and again, Studio Web. Name is the same, but icon is different. Is this a different service or is it the same? I have no idea. And then things are getting more difficult. There are some Azure Databricks, HDSI, Data Factory, and what to use. There's another interesting section which is called What's New. And here we have other services. But here is, remember, here's section What's New. And here we see one marked as retiring. And then there is this saying that your code becomes obsolete the moment you commit that. Maybe that's true as well. But okay, let's get serious for a while. So what do you mean by saying making data scientists productive in Azure? I mean this cycle of having data, preparing that data, training, and deploying. So I'll go through those available tools in Azure via perspective of this diagram. Like how this is different than traditional software development. Like with traditional, you will look maybe at one database, a few frameworks. But here, when you ask a data scientist or data engineer, so what connectors to what database you would like to have? Everything. What tools you would like to use? I don't know, Python, R, maybe something else. I want everything. So the idea is to have this cycle and just look what tools support what languages. And then we have scale everything and have ability to tune. And then we have logging, which is those are kind of things that we are not sometimes thinking about that should be there, but apparently not every service has those. And for today, I prepared those 6 data science stories. So names are fake, photos are stock photos, but the problems they are dealing with, those are real problems. So our first hero is Tom, and Tom is a software developer. He knows Android, he knows Node.js, he knows React, and he wants to create a solution to scan faces and show ads. And there was one situation in Oslo 1 year or 2 years ago when there was Pepe's Pizza, and Pepe's Pizza was showing ads based. If you are a male, it will show you ad with pizza. If you are a female, it will show you ad with salad. So then everyone started shouting that it's privacy and you should not do that, so they removed. But Tom is not concerned about privacy, he wants to get this thing done. So what he started doing, he started learning data science, and you see he's concerned because it will take 3 months to learn data science and then another 6 months to actually implement that thing. So in this case, I would go with Azure Cognitive Services. So those are pre-built ML tools available in Azure with exposed as APIs. Simple overview, we have text analytics, we have computer vision, speech recognition, language understanding, and we have search. As with some presentations at Microsoft, you might hear, let's Google that with Bing. So search is based on Bing API. And I tried my picture. So I tried to look, I don't know, excited, that's difficult to say. And I was expecting to see skin color, to hair color, or just my emotion. But the very first property, as you see, is this. Yes, that's true, I'm getting older, that's a fact. But that's not the reason to put it in the first place, I think. But then, okay, in the case of Tom, he wants to show those ads, right? So he gets immediately a response that this man is bald. Okay, so if, let's say, this baldness level, if put so, is higher than 50%, then maybe they already lost their hope. And you should just show an ad of hat because it's cold outside. But for guys like me, and I see you, my friends, as well, some of you, like in that case, maybe you should show ad of, instead of buying cheap Head and Shoulders, you should buy an expensive shampoo that will maybe stop things, at least for a while. And I was surprised by my wife. I showed this picture to my wife and she said, wow, this is nonsense. Only 0.13? It's at least 20. Yeah, I love her. But I don't want to spend a lot of time on cognitive services because those, I think, for this audience are not that interesting because we cannot edit or we cannot modify a lot. But just be aware that those are available in Azure. So we have minimal development effort. We can integrate with HTTP, and there's built-in support with other Azure services, like out of the box. Considerations that in most of the cases only online, only partial customization available, and limited supported for non-English. So if you would like to have analysis on English language, then cool. If something else, if Lithuanian, then you might look for something else. For example, for Lithuanian language, the cool services provides Latvian company called Tilde. By the way, I was very surprised. Let's go to another hero. Another hero is Mark. And Mark is a business analyst. He has basics of statistical analysis. And his boss thinks that he knows Python and he can create a sales lead. Why his boss thinks that? Maybe because someone wrote that on his CV, that he's an expert of that. And now Mark has to do create that sales list. So what I would recommend in this case is another service called Azure Machine Learning Studio, which is available in Azure. It's based on UI with drag and drop, and you can build, experiment, and deploy your services there. It looks like this. So we have all the boxes. The first box is we are importing data, we are making some pre-processing. Then we are having a couple of algorithms, and we can evaluate those. And we can choose from different data pre-processing, data cleaning. It is drag and drop. There is no customization, so you get what's there. And the same applies for those algorithms. You just drag and drop. And then you can compare those different and just go with the one algorithm which performs better. When it comes to deploying things, you add additional boxes, input, output, and you can get to web services, which is batch web service or request response. So you might ask, so okay, that looks kind of nice, but what is the catch? So the catch is if you try writing custom code or doing something that's not aligned with Microsoft idea, you will see this. Something happened. I have no idea what. Contact user support. So as long as you are not using any customization, this tool works pretty well. But if you start writing your own code there, you might see this kind of message. When it comes to this cycle, so data that is, or data connectors that are supported by Azure Machine Learning Studio, those are different databases available in Azure. For data preparation, it's only Machine Learning Studio. Training, only Machine Learning Studio, and for deployment, web services. And interesting thing is that you can scale storage, you can scale web services, but when it comes to preparation and training, there is no scalability. You cannot increase the node sizes. It's just what you get. So benefits, as I mentioned, if someone lied on their CV that they know Python, but actually they don't, so this service, I think, is kind of for business analysts to make things quickly possible. But be aware of the limitations. The maximum size of training data set is 10 gigabytes. That's it. There is no way to increase that. Online only and limited support for custom code. So let's dive further. Here's Lucy. And what do you think when you look at Lucy's picture? What's the main emotion? Or is she happy? Or yeah, a bit happy, but I think it's more that like she's upset, and she's a professional machine learning engineer, and she's been asked to estimate damage or repair cost in auto industry. But the thing is why she's unhappy, because the last time she's been asked for create such model, Java backend team, what they did, they actually took her code, took her Python code, and they had no idea how to execute that, so they rewrote that in Java. And I've seen such things happening quite a lot when they just, okay, this is pretty much this is what you have, so we'll rewrite because we know Java. And then you get this. You get a picture, and the only thing that's, according to model, that's wrong with this car is just one small thing, missing headlight. Apart of that, that's drivable. So the thing that Lucy might find interesting in Azure for this, and remember, she is Python developer. She doesn't want to go with this drag and drop and just be on mercy of Microsoft. So the service is called Azure Machine Learning Service, not Studio. Those are two different things. So as I mentioned in the beginning, they have maybe some difficulties of naming those, but it's service. And it's managed ML service in Azure. It's based on Python SDK, good for data preparation, and we would like to focus on this compute targets, experiment, tracking, and deployment. So imagine you have a Python script, and you are running that locally. So it works. Like in Lucy's case, she has those 100 of pictures, and she's running that locally. But soon the RAM and the PC is not capable of kind of running that experiment. So she wants to execute somewhere in the cloud, in virtual machine or somewhere in the distributed computing. So with a small changes to her Python code, it's possible to execute that in Azure. As I mentioned, it's local computer, and there are a few options that are supported by this SDK. So maybe a one huge Linux VM, maybe a distributed computing, maybe a Spark job on Azure Databricks, or something running in container instance or Apache Spark on HD Insight, which is Hortonworks distribution. But now let's take a look at code. So how it looks, we have some importing libraries. At line 6, we are providing secrets because we are already supposed to have Azure account for this. On line 8, I'm saying that, look, I would like to have GPU-based cluster with 4 nodes. And then on line 13, we're creating that. On line 15, we're creating experiment, kind of placeholder for that. And line 17, so we are linking our training files. In this case, it's PyTorch. So training files together with compute. And we are submitting in line 22. So if we would like to use something else, not this batch AI GPU based, but something else, so then we edit line number 8 and we run with something more powerful or maybe on another type of cluster. But the issue with such running on like spinning up clusters right and left, the thing is that those things cost. So in my case, the biggest so far like problem that I had with Azure pricing was that at the beginning of my journey with Azure, I had no idea what's the difference between stopped virtual machine and stopped deallocated virtual machine. Like technically, both machines were not accessible, but for one, we're still paying, for another, not. So I figured out that after 2 weeks, and that was not the cheapest machine. But I'm still working to work. And sometimes you might face something even more extreme. If you spin up a huge cluster, then your boss might not be that happy. Okay, but then there is another thing. Let's say we are running our jobs in distributed computing, how to track what's happening. So that SDK has another thing called experimentation, where you are able to track all the metrics in Azure. If we look at the code, we have the same. We're getting secrets from config. We are creating experiment, and then we are logging. So actually, we are sending our logs to Azure. And in addition, on line 10, you can notice we are uploading, in addition, our model. So we could have multiple iterations with different metrics, and then choose the one model which performs best according to the one that you want, the metric that you chose. Where do you see those? There are a couple of options. Installing that in Jupyter, and it shows the whole run history, or you go to Azure and you see how it performed. What's there in addition, what Microsoft is suggesting or that's trying to use, is auto machine learning, where you specify a group of algorithms, classification or regression. You specify a threshold that you would like to kind of look at, and then you run multiple iterations and let the Azure just stop once it reaches a certain algorithm, it reaches your threshold. And then you can choose that, okay, this algorithm or this model is fine enough. Where can we deploy? So native support is for things that are in Azure, container instances, Kubernetes, or Azure IoT Edge devices. If you would like to deploy it somewhere else, let's say virtual machine or other cloud provider, then things are not that simple. The only deployment option is you get your model file and you just wrap that and deploy according to other cloud provider needs. But there's no out-of-the-box support for that. How it looks from the diagram, so as you noticed, we have a model. So then there is another thing which is called image. So image is your scoring Python file and your model file. Basically, you describe how to use that model. And then on top of that image, you can create a web service, which you can just give a link to your colleagues, or in Lucy's case, that Java team where they can execute. How it looks from the code? On line number 7, we are sending that model to Azure. On line number 9, we are specifying that this will be my scoring file. On line number 13, we are kind of linking this our model file with scoring file. And then line number 18, we are creating like the place in Azure to execute that. You can see that we are specifying we need 1 core, we need 1 memory gigabyte. And then line number 20, we are creating that web service. So we are getting URL already in Azure that we can kind of ping and get predictions. How it looks from this diagram. As you already see in the data, there is only one icon, which is blob storage. So it's quite, in order to have this ability to execute and have multiple compute options, you need your data in blob store. For data preparation, anything that you want from Python, there is no R. There is only Python in this case. For training as well, choose whatever you want and send to some computing machines. And deployment, as I mentioned, Kubernetes or Azure container instances or IoT edge devices. So, shortly, benefits. You see history. So it's the only kind of all-in-one framework in Azure where you can see history. You can send those to different computes. And there is option to deploy to Azure Kubernetes or container instances. And you have control over those. But considerations, it's still in preview. So as it happens with some services in Azure that are still in preview, it might change. And it's Python only. So then we have another person, and this is Rick. And Rick has an issue. He specializes in R. Oh, like specializing in R is not an issue. Issue is that he is not able to push data to Azure. And is there any service provided by Microsoft or by Azure that you can use? So in his case is Microsoft Machine Learning Server. And the idea with the server is installation thing that you can install on Windows or Linux and start using that. And it covers the full cycle as well. Like short overview, why do you think previously it was named Microsoft R and now they renamed to Azure Machine Learning? Because someone from sales team, they thought, well, like, we need Python as well, so let's just rename at the same name as those previous 3 services are named and just call everything machine learning. But you can install on Windows, Linux, or Hadoop cluster, deploy models as web services, or just create Docker container. And the last point regarding security, so you can install this on your premises or in Azure Virtual Machine, which in case of on-premises, you fully control of all the security things if you are not allowed to use cloud for some reasons. How the cycle looks like? We have data that can come from anything you want. There is no limitations. Then data preparation is mainly R, and Python is supported. It's Conda installation there. For training, R as well. And for deploying, it's Docker images that you can do whatever you want with that. So it's built on Microsoft's like R Revolutionary R Enterprise, and this is the reason like this is probably the most enterprise-ready R installation that is available on the market. Advanced security options, and you can deploy R or Python models as web services, and this can be done via code, and data scientists can do that. There is no need of having separate DevOps team setting this up. But consideration says that you have to install that somewhere. So someone has to take care of that machine. So I'm not sure if in all the cases data scientists, they want to be admins, or the question is, do you have that machine somewhere on premises? Another hero is Bradley. And Bradley is a data scientist. He knows Apache Spark. He knows SQL. And his motto is, as you see from the picture, he likes mountains. So he wants to spend more time outdoors than just playing with some preview tools. He wants stable thing, because the problem he's been asked to work on is help structural engineers to monitor the health of the bridges. Do you know this game? Pontifex, yeah. With my colleagues, we're playing this and trying train, because the idea is that you build a bridge within the budget and train has to pass both ways. So with Friend, we try to do this a bit another way. Use as little materials as possible and let the train pass just one way, and it should crash on another. I guess if I apply for a work to some company that does that, I shouldn't mention that. But Azure Databricks, it's something that's probably the most mature offering in the whole Azure. And it's Spark-based analytics platform. And how many of you are familiar with Azure Databricks or with Databricks on the AWS? Yeah, I see quite a few. Are you working on AWS or Azure? Cool. I want to speak with you afterwards. So what we have there, we have workspaces, notebooks, user accesses, Git integration. We have Databricks runtimes. Those are Spark images that Databricks provides, where you can expand with your own libraries. You can deploy jobs or workflows. You have job scheduler there. And when it comes to security, there is single sign-on, which comes by the default, and it's for the enterprises, that's a pretty important thing. Access control list, and another important thing is secrets, which they added lately. Like in your notebooks, you don't see passwords. So your data scientists, they don't need to know what passwords or users you are using. You just create on Key Vault and let the security department be happy with your cluster. How it looks like, that's not a rocket science. We have a notebook. We have a few commits. When it comes to creating new clusters, you specify what type, what version of the cluster you want. You specify Python version, and you can specify how many workers you need. If you want to auto-scale this, you specify the minimum amount, the maximum amount, and let the Databricks do the magic. And another interesting point is terminating after a certain period. So if you are not working with that, let's say for half an hour, or in this case 120 minutes, the cluster will shut down and you are not paying anything. So there is no instance like I showed in this comic that, oh, someone forgot to shut down on Friday. So this will shut down automatically. How it looks from this cycle, the data, they're just what connectors, Spark connectors you can find, or you can go with pure Python. Data preparation, training, whatever you kind of imagine. But for deploying, you might use another service that I showed you previously, which is called Machine Learning Service, if you want to deploy to Kubernetes or Docker, or use this logging or model maintenance management. Another interesting tool that was deployed by Databricks was MLflow, which is still in beta, but it's really a great tool for deploying your workflows in any cloud or in any virtual machine. So I think that's a game changer. So Azure Databricks, it's probably the most mature development environment in Azure that you can find as of today. And it's nicely integrated with Azure other services. So because Databricks and Microsoft team, they work really closely. And for instance, we are using SQL Data Warehouse, which is distributed SQL in Azure. And the performance is absolutely amazing between those two. Considerations, online only. Another consideration that it's you have to pay for license for Databricks. Like they do it for every computation. Let's say you have a virtual machine of certain size. So then you have to pay certain percent to Databricks for that. And the last hero is Joshua. Joshua is a data scientist. He works in research and development department. And he said, I don't want to play with your Databricks or right now to choose machine learning service or studio, whatever. I just want to try something that's available new. Just try how that works. So in this case, I would recommend going with data science virtual machine, which is nothing fancy. It's just virtual machine image, pre-installed image with all the popular software that right now are popular in the market. So Microsoft created that image, and you are not paying for license. You are just paying for this virtual machine where you install that image. So different languages, data tools, deep learning, But you can install things in addition on top of that. But you might say, so Valdas, what are you talking about? This is just a simple virtual machine. That's not a platform as a service. This is not an environment for data scientists. Well, yes, this is just virtual machine. But if you would like to have full flexibility of what you are playing with, so this is, I think, good kind of start. And another interesting thing is GPU. So you can choose Azure GPU servers, and this image is already configured. You don't have to play with the drivers to set up that. It will work out of the box. So key benefits. In this case, it's not the most mature as it was in Databricks. I would say this one is the most complete. So you can have very different things installed here. Reduced time to install includes the latest versions. I'm not sure if those are the latest. Sometime maybe were the latest. So Microsoft is updating those images quite often. And as I mentioned, GPU images and considerations is online only. Again, so if this is a concern that you will have to work remotely or via SSH, so this is something to consider. So once again, a little exam. So we have Azure Machine Learning Studio, which, as you remember, is this drag and drop for the guys who lied on their resumes that they know Python, but actually they want to drag things more. Machine Learning Service, which is this, right now it's in preview, but it's really promising service for experimentation, for different compute targets, for different deployment options. And previously it was called Azure Machine Learning Workbench. So just don't get confused over that. Workbench is gone. Now is service. Microsoft Machine Learning Server, which previously was called R Server, but since they added Python, they just changed the name to Machine Learning Server. And Data Science Virtual Machine, which is basically image in Azure. So this is it from me. Do you have any questions?